Hello. Yeah, this is my seventh episode, and this episode is going to talk more about acoustics, noise, and vibration. This also includes the harshness part, which will be discussed in the next episode. So, the last six episodes had been focusing completely on the structures, the structural simulation aspects, various kinds of structural simulations, various kinds of failures acted upon a structure based on the kind of loadings, based on the kinds of uh, environment to which the structure is exposed to. So we have seen what exactly happens to a structure when there is a dead load accumulated. We have also seen what happens to the structure when subjected to rolling loads or influential loads or live loads. We have also seen what would happen to a structure when repetitive loads or cyclic loads occur on the structure. And we also have seen the various other physical aspects or various other physics involved in the structure, say rise in temperature or the structure when subjected to airflow, the structure when subjected to seismic loads, the structure when subjected to a blast load. We have seen all kinds of uh, structural deformations that generally occurs on structure. So this particular episode we are going to focus on acoustics and all the other dimensions of acoustics like noise, vibrations, and harshness. So here some examples that we have seen earlier are about the structural vibrations inside a cooling tower uh, occurring on an induced draft fan impeller. And we have also seen the flow inside a chamber, and because of those flows, what are the kind of disturbances caused on the structure. We have also seen an explicit condition of an aircraft flying at a higher altitude when subjected to impact of flocks of birds flying along the direction. So, what would be the kind of damage that could occur on the aircraft? So, that is again one particular case that we have seen. We have also seen what would happen when there is a high speed bullet train that runs on a bridge, a rail over bridge, and what would be the kind of loadings that can occur on the structure and how the shock loads are transmitted from the deck to the pier, to the pier wall, to the pile cap, and to the pile, and then to the foundation. We have also discussed about the impact, the possible impact that comes on a battle tank, and how the hull of the battle tank tears off. We have also seen what would be the possible damage that can happen on the battle tank shell or the hull because of the recoil ability of the gun, the turret control systems, etc. So here we are going to analyze the structure slightly magnified. So here we are going to deal with acoustics. So as I told you, there are three kinds of results that occurs from a structure that is under operating condition. So one will be that there is a specific work done, and the work done, the resultant of the work done will be in the form of a noise, it will be in the form of a light, etc. So when the machine rotates and when two or more parts come together in contact, there are possibilities of temperature rises. So there is a thermal distribution happening within the structure. Also, the mating parts, when rubbed together, they also create noise. And these noises are created because of the vibrations that occurs on the structure. So there are two types of vibrations. One is the structural vibration caused by the structure within the structure. And the other one is the vibrations caused because of a certain airflow. So here the airflow will be acting as a conductance. So the possible noise gets absorbed by the air and then that gets transferred to different mediums. So air is a medium, water is a medium, solid is a medium. So these vibrations can diffuse in all these three mediums. So acoustics, noise, and vibrations are interrelated fields, generally dealing with the study of the control of sound and mechanical waves. So what are mechanical waves? So these mechanical waves are nothing but it can be the waves because of a certain pressure. So there is some pressure exerted on a structure, and that pressure will be transmitted in the form of mechanical waves. And acoustics is the science of sound and its behavior, while noise is an unwanted sound. So acoustics is a science of sound. So acoustics can happen anywhere. Acoustics can happen in a residential structure. Acoustics can happen in a musical instrument, a guitar or a piano. And acoustics can happen in an aircraft. And acoustics can happen within a machine. Then acoustics can also happen in any of the kitchen structures or home appliances. So here we are going to study the effect of sound and its behavior. And from that, we are going to categorize the other aspects of the sound. So noise is the most, it's called as the unwanted system. It's generally called as an unwanted system because noise is something that people don't prefer, and sound is something that people prefer. So the music is again a sound that comes from the musical instrument, the piano or the guitar, which is beautiful, which is pleasant to hear. Whereas the noise, which is usually harsh in nature, is unpleasant to hear. So these vibrations are generally the oscillations. Vibrations are the oscillations of the objects that can generate sound and noise. Say, for example, let us take the case of a musical instrument. The musical instrument has got strings. The guitar or the violin has got strings, and when we strike against the string, there is a vibration caused, and this vibration gets inside the mechanical system, that is the enclosure of the guitar, and that starts reverberating. And this reverberation, the resultant of this reverberation, is concluded in the form of music, which is pleasant to hear. And some other areas where when this noise, I mean, sorry, the sound that becomes unpleasant. Say, for example, the car. So within the car, there are different subsystems. We have the engine system, we have the steering system, we have the seating system, we have the interior systems, and then we have the exhaust system, we have the powertrain system, we have the tire systems. So we also have the suspension systems. So we don't, let's not leave anything here. Let's consider all these systems. Now, when the car is at rest, there is absolutely no noise. When the car is in dynamics, when the car starts moving, rolling forward, and it speeds up, there are a lot of noise which is exhibited. So the noise because of the engine system, the noise because of the tire and suspension system. So there are many contributing factors, and ultimately all these noises are getting diffused inside the cabin. That is the vehicle cabin. The passengers as well as the driver all are present inside the cabin, and these external noises are going to contribute, and these contribution factors are going to affect the passengers and the driver inside. So now it's the duty of the automotive OEM to ensure that all these kinds of noise, the passerby noise, the engine noise, the gear rattling noise, the powertrain noise, the exhaust noise, and the tire noise. So the vehicle, when moves on different terrains, will start exhibiting different undulations, and these undulations are going to impart vertical and horizontal loads, impact loads onto the chassis structure, and from the chassis it goes inside the seating systems, and from the seating systems it again gets diffused inside the cabin, the vehicle cabin. So, in some cases, some structures carry pleasant noise. The output, the resultant will be a pleasant noise. In some structures, it becomes very unpleasant and unpleasant noise. So, let's try to break down these particular aspects of acoustics. So, as I mentioned a few minutes back, that acoustics is a branch of physics that studies mechanical waves, that studies the effect of mechanical waves in three different states. So we know that the three different states of nature are solid, liquids, and gases. So how would the mechanical waves, the behavior of the mechanical waves occur when it passes through a solid, and how it behaves in the form that is when it enters a liquid, and how does it behave when it enters a gas medium. So that is what we'll be studying in acoustics. It can also encompass the study of sounds, ultrasound, infrasounds, and vibrations. And there are many applications which is generally connected to it. As I discussed earlier, it will include the sound recording and reproduction of architectural design. Say, in most of the media or the cinema related fields, theater related fields, there are a lot of dubbing sessions happening. There are a lot of songs going on, and just before mixing the visual to the audio, they need to enhance the quality of visuals and the quality of audio. So, what I mean by enhancing the quality of audio or video is when the initial recording happens, there is a certain aspect of certain factors which is present, the impurities, and these impurities need to be removed. And generally, they are octaves. There are called octaves, and there could be the repetition of these octave bandwidth. And what happens is possibly it's a mixture of both high frequency, low frequency, etc., and from which you need to uh, cut off the peaks. So there is some level of amplification done to this, which we call as the amplification factor, and that amplification factor does the degaussing and denoising activities. So which means the impurities from that particular sound wave is removed, and then it's made pleasant to hear. So this particular activity happens in those structures that are generally adopted or designed or developed for pleasant noise. So example is our cinema theater where the movie is run, and there is a possibility of echo within the room. The noise from the screen, the noise from the back, the noise of the people inside, present inside, all can interact with one another, and the dominant frequency will show up. So in such cases, these unwanted noise or the unpleasant noise has to be removed, and this part of removal happens through using materials, different kinds of materials. There are different kinds of materials that are quite capable of absorbing noise, the sound, and it reduces the reverberation. So based on the Savine's law, we know that the time taken for the sound wave to go hit the surface and then come back. Okay, so that's called the echo, and the echo is completely cut off, reduced. So what they do is the flooring, the roof, the side walls, etc., are all perfectly, uh, handled or uh, applied with materials that can diffuse. I mean, noise absorptions take place. Okay, so now let's get into the unwanted point of view. Say, usually what happens is we have seen in the railway stations or in the airports, too many people they gather together, and few people they talk very gently, and few people they are a kind of harsh. They try to raise their voice, and they're like different kinds of people and different kinds of uh, phonetics, different kinds of sounds generated or propagated. So within a huge enclosure, all these noises put together, okay, the resultants can occur in any direction. And in order to reduce this effect in the enclosure, that is within the airport or the railway stations, there are solutions which is implemented for these structures. So generally, we find the mid-frequency to high-frequency noises occurring on the structure. So there is a generator, and this generator is operated, and that generates high-frequency noise. And then you also have the train horning. The train horn is again a noise. Okay, so that will be of a different intensity. So like that, you'll have 10 or 15 different elements, sorry, with various frequencies. And in this, the dominant frequency will be the one that is going to be projected. Okay, so nowadays there are a lot of solutions, acoustic solutions, that particular subject, I mean the structure or the structure, sorry, the equipment are all completely what do you call uh, checked for regulations, check for the noise regulations. Say for example, uh, we have a this one homemade sorry, an equipment, a home appliance like your mixer grinder. Okay, and this mixer grinder operates at a certain frequency, and it exhibits a certain level of noise which will be marked in decibels. Now there is a regulation which states that all the home equipments should be operating below, say, about 60 decibels or say 55 decibels. So which means that mandatorily all the product development companies that is focusing on designing the home appliances are supposed to keep the operating conditions based on the regulatory. Say if it is 50 decibel, it should be strictly 50 decibel. So there are generators, huge generators, and these generators operate at a higher decibel ranges. See, some go up to 85, 90 decibels. Okay, and the actual regulatory says that this particular generator structure has to be kept completely away from the residential area, and it should be having an enclosure, and this enclosure should be able to contain the noise which comes out of the generator, and the resultant noise should not exceed more than 80 decibels or say 75 decibels. So based on that, these generators are designed. So similarly, an aircraft, similarly a vehicle. So every structure has got a specific regulator. Okay, and the authorities are very strict and stringent onto the norms. Okay, so let's say that there is a factory, and this factory is operating from morning 6 to the next day morning 6. That's the complete cycle. And in this complete cycle, almost about 60 or 70% of the time, there is a huge amount of noise emitted onto the atmosphere. And these noise in the form of pollution is going to affect the people staying near around. So there could be a possibility of residential structures and people continuously subjected to this noise, high frequency noise or low frequency noise or mid frequency noise. Okay, they can over a period of time get into some kind of psychiatrical damages. The ear can damage, okay, and that will affect, that will be a kind of handicapness, and that will affect their career or profession in the long run. Okay, that can also create some kind of psychiatric issues, and that can completely create a pressure onto the family, and the family life can get into a different mode. So these kind of environmental regulatory is maintained by the pollution control board. And as I told you, these vibrations are nothing but mechanical oscillations which occurs from an object, and then from that object it will get diffused onto the other structures, I mean sorry, the other mediums. The noise will travel in different mediums. One will be solid, okay, and the other one will be a liquid, that is water, or maybe different kind of viscous material. And thirdly, it's a gas. Okay, air is a medium, and the noise can also get diffused. Okay, the rate of uh, noise propagation will also depend on the medium through which it is moving. So these sound waves, okay, that is generally propagated, okay, from the source. A loudspeaker can be a source, okay, and from that source, when it travels to the sink, there is a good amount of damage that can happen in between the source to sink. So to reduce that, we try to develop the product, we try to design the product in such a way that all these regulatories and norms are all taken care of. Okay, and we use all kinds of software tools or testing tools to ensure that this particular product is 100% safe and it's viable. So there are different kinds of acoustics. That is, we have engineering acoustics, we have architectural acoustics, we have transportation acoustics, we have industrial acoustics, and we have environmental acoustics. These are the different types of acoustics. And I told you about the engineering acoustics a few minutes back, about the noise propagated from the car when it is rolling on the road. That's a typical engineering application. Then we have architectural acoustics. I gave you an example about the cinema theater or the studios, the musical studios. Okay. I also gave you an example about industrial acoustics. So within an industry, you have more than 50 or 100 machineries functioning at the same time. Some machineries are used for some specific applications. There will be a lot of bump loads. There will be a lot of uh, vertical loading acting and the horizontal loads acting simultaneously. There could be a rotational force acting on the spindle shaft systems. So that's again a type of loading. And all these loadings are going to impart some or the other kinds of vibration. And as I told you, that once these products are properly, they are kept intact, these vibrations can be reduced. And they also need to make use of materials, nonlinear materials or hyperelastic materials like neoprene, okay, which is supposed to be good dampers. And only when they make use of the proper dampers and when they properly check for the mating or the connectivity between the parts, they will be able to reduce the vibrations. And as I told you, that these kind of structural integrations are immensely important in, especially in the aircraft industries, because when there are undulations, that is dangling structures within the systems or the subsystems, these can influence in individual vibrations and resonances. And the resonating forces or the resonation or the resonance will be the only reason that the structure can damage or it can fail. Especially the aircrafts. Aircrafts are subjected to wind tunnel testing and to check for the flutter systems. So they study the natural frequency. They also study the forced frequency. Okay, they also uh, fabricate. I mean, use the proper fabrics within the structures, and they check for. I mean, they try to arrive at the proper damping factors, and then they check for the structural integrity. If there are too many harmonics, okay, and all these structures connects at a single frequency, that is a resonating frequency, the structure tends to get damaged. So similarly, uh, like many other structures, say for example your windmill is again a giant structure, and that has got different about different kinds of loading. The wind load is dominant, and because of the wind load there will be a lot of rotations moments occurring at the hub, and the structure, the structure can also resonate. Okay, there are different modes, and based on the different modes, the resonating frequency is determined, and then they completely try to eliminate the resonating frequency by using the proper material, nonlinear materials, in order to dampen the vibrations. Okay, so these are called when two or more structure made together and then there is a vibration. We call it as vibro acoustics. That is the acoustics generated because of the operating conditions of these structures, two or more structures. Now, when a plane moving at a higher atmosphere subjected to too many aerodynamic loadings. Okay, because these aerodynamic loadings are the ones which is going to create the lift and drag, and it's going to keep the aircraft in the scene, in the wind. Now, if any of these parameter changes and suddenly there is a air pocket or turbulence created, because of the turbulence, there is a tendency for the structure to collapse. Because we know that an aircraft is a thin shell, and this thin shell structure, like similar to your pressure vessel, industrial pressure vessel, it's on the upper atmosphere. So there is a huge amount of difference in the pressure inside and the pressure outside. So in the ground level, there is going to be an atmospheric pressure one, and as the altitude increases, the pressure drops. And when the atmospheric pressure drops, there will be the pressure. Okay, the pressure has to be maintained inside the aircraft. And if the pressure isn't properly maintained in the aircraft can cripple, or there can be a buckling, or there, the structure, the entire structure can shrink. It can, collapse because of buckling and crippling loads. Okay, so now, these kind of structures are generally subjected to wind tunnel testing to find out what are the effects of aerodynamic loads influencing on the structure. Okay, so we discussed about the high frequency and the mid frequency zones. Okay, and generally what people are experiencing. Now there is something called low frequency noise, that acts up to a couple of hundred hertz. that is from 2 hertz to 100 hertz or say 200 hertz. Now this is generally considered to be the low frequency zone. And now the low frequency noises are very, like very disturbing noise, very low humming noise for a long period of time. See, especially these kind of noise get subjected, in certain home appliances, especially the cooking ranges. So the women who are within the kitchen, involved in the cooking activities, they stay in the kitchen for a very long time. They experience this cooking range noise, low frequency noises coming from ducts, etc., AC ducts and all. Now, over a long run, this will create issues, all kinds of mental issues or psychiatrical issues to the women. It can also create a big problem in the eardrums. Okay, so now there is a process through which the low frequency noises can also be eliminated, which is generally called active noise cancellation, where they cannot use any fabric or any material as such. Instead, they make use of speakers and microphones. Okay, assuming the concept that for a certain noise of a certain frequency, there is an anti-noise which is developed, and these two noises of a certain amplitude, one will be the positive, the other one will be the negative, and these two combined together neutralize, and then that particular noise is reduced. So based on this particular concept, today many automotive OEMs and home appliances companies and aircraft industries and even the industries, the machine building industries, they all use active noise cancellation technique readily. So earlier, this particular problem used to be solved not completely, but using earbuds. So now earbuds, the cancelling the noise at the earbuds, instead they create a zone or a bubble across the head of that particular person. Okay, and within that particular specific bubble, the whatever external noises come, that gets completely cancelled. The moment the head goes outside that bubble, the person will be able to hear the other external noises. So especially, this is the same thing which happens in the car, where the headrest, they open the headrest and they mount the speakers, and they also mount a microphone, and whatever noises which is getting diffused inside the cabin, the vehicle cabin, okay, that particular dominant frequency, for analyzing that particular dominant frequency, making use of these controllers, okay, speaker microcontrollers, they generate, that is, the system is capable of generating an anti-noise, and this anti-noise can cut off all the dominant frequencies, and within the passenger vehicle, the complete sound, the noises are diffused, and then it's silent. And the technology has gone to an extent, especially in acoustics, the active noise cancellation technique, that each passenger will be capable of hearing his or her own songs as per her wish, his or her wish. Okay, so now we have seen what is acoustics, what is noise, what is vibration, and what is harshness, and how it is going to be influencing the environment. What are the impacts occurring on the people? Okay, so we also have found out what are the suitable solutions that can be used. So today, this particular session, I'm going to conclude, and I think that I've fairly given a good idea about what is acoustics, noise, vibration, NVH, noise, vibration, and harshness, and how this is going to, create issues within products, all kinds of products, home appliances products, industrial products, transportation products, all kinds of products, and how this can be solved. Okay, so the next session I will discuss in detail about the durability process, and also how the NVH, the noise, vibration, and harshness, is accounted in the certain industries, the automotive industries. Okay, so thank you very much for hearing this particular video. And I would again, okay, as before, I would again request you to kindly subscribe this channel so that you will be able to visualize, you will be able to hear a lot of very interesting videos, which is already there in our stack. Okay, so you subscribe this, you can also share it with any of your friends that would be more interested in hearing these kind of advanced topics. Okay, this is something which is explained out of experience, because this is what I want to give you rather than the informations which is replicated from the books. Okay, so this is in nutshell, this is a capsule kind of course or a discussion which I'm trying to give to those engineers who are working presently or who will be working in future along these industrial areas. Okay, so thank you once again. Okay, please subscribe and share this video. Thank you very much.